Hi everyone. Yeah, I think it's time for a quick introduction of myself right now. So this is Luis here, and I'm the product manager of the Anomaly Detector service. And thank you so much for joining this session to listen about how we can use 5 popular ways to use Anomaly Detector to do anomaly detection. So without further ado, let's jump into today's session, and I will present my deck right now. So Albana, if you can hear me, can you let me share my screen and present this? Okay, cool. I think we are working right now. So let me just go into the present mode. Okay, hi everyone, and today I will show you 5 popular ways to realize anomaly detection with our Azure Anomaly Detector. So, if you have first time to hear about Azure Anomaly Detector, let me give a quick introduction of what it do and how it works. So, Anomaly Detector is a service located in Azure Cognitive Services. As you might know, in Cognitive Services, we have language, speech, decision, and vision. We have different pillars, and within the decision, we have the anomaly detector, which will help you to do the anomaly detection and will help you to make the right and correct and also the timely decision for you and your business. So the rationale of anomaly detector is pretty simple. We will use your time series data and to use that and pass them into the anomaly detection models, and then we will give you the output of whether it is anomaly or not, and when is anomalies, and also the root cause of these anomalies. So basically, this anomaly detector is a set of API services with AI models. So it's really easy to integrate, easy to use, and easy to forward looking at. So within Anomaly Detector service, we have 2 features right now. The first one is the univariate to the left, and the second one is the multivariate anomaly detection. So the difference between them is pretty simple. For example, for univariate anomaly detection, you can see there is only one variable, which is one time series data here. So in univariate, we will detect one variable's anomalies. For example, in your business metrics like revenue, cost, etc. You can detect anomalies, whatever you want. And for other metrics like your CPU, your bandwidth, your networking, if you just have one variable, then the univariate anomaly detection will be the better choice. And if you have a really complex equipment or a really complicated system, like you have an equipment, you have a pump, and you have a lot of sensors integrated on that, so you want to detect whether this pump is anomalous or not in a system level or in an equipment level. So you can use the multivariate anomaly detection instead, because it will not give you like one variable's anomalies, but it will give you on a system level whether there are anomalies for this pump. And one is anomalous, and also will tell you once this is an anomalous timestamp, whether there are some root cause analysis, like which sensors are the contributed ones to this anomaly. So this is the amazing thing for multivariate anomaly detection. And talking about the status of these 2 features, the univariate is already GA and the multivariate anomaly detection is in public preview. But good news is that we will GA in this November. So stay tuned and looking forward to that. And most of you may probably be interested into the algorithms behind them. So for univariate, it's more like a model selection work. So the process is also simple. You will not need to train a model. Instead, you just pass your data for inference to the univariate anomaly detection API, and they will do the inference for you automatically. And behind this scene is happening on the model selection. So based on your data pattern, the univariate anomaly detection, which is also shortened for UVAD, can select the right model for your data pattern. So we have different models you can see here. And also for multivariate anomaly detection, it's a little bit complex for process because it's a more high level or equipment level detection. And most of the time, the equipment is pretty expensive, like millions dollars or $1 billion, right? So we have to use your own data to train a model. But the training process is also simple. You don't need to like adjust a lot of parameters. You just need to pass your training data set into our training API, and then we will train a model for you. It will take some time, around 1 hour or more than that. It all depends on your data size. And after you train a model, you will use your trained model to do the inference, to trigger the inference. And after you trigger inference, you can get the details and the anomalies out of this model. So for multivariate, the model we're using is the graph attention networks. So since we are using these attention networks, so we will learn a lot of feature relationships between the samples, which is between the variables at different timestamps and time series. So for multivariate, it will not only detect the spikes or drops or the trend change, but it will also detect the correlation changes between the variable. For example, the temperature and the humidity have a correlation, but I sometimes they just have a big change on this correlation. Like they will not have any correlation at all or other changes. So at this timestamp, we will definitely detect this for you. So you will know that this time is a disaster or there might be a disaster to help you do the predictive maintenance. Okay, so this all for the overview of the Anomaly Detector service and also the features within that. So let's go deeper into this before we go to the 5 popular ways because we want to make sure that we are aligned and we have a better understanding of how it works. So the first is the univariate. We have two major APIs, which is the last API and also the entire API. So the last API is to detect anomaly status of the latest point in the time series. And the entire is to find the anomalies for the entire series in batch. So if we change the wording a little bit, so the last detect is more for a streaming scenario, and the entire detection is more for a batch scenario. And in the picture down below, you can see the different anomalies that we can help. So the first is some spike and drop, or some trend change, or something that is out of the regular pattern. So that is the univariate. And the univariate technical overview or the basic architecture is pretty simple. So you just give your one variable into the Anomaly Detector API, sorry for that, and to inference on your real-time data. You can either use the last detection or the entire detection based on your validation purpose or your real-time detection purpose. And after you get the results from the Anomaly Detector, you can do the validation with your data scientist and also your business side. So the reason why we involve these two kind of persona here is for first one, the data scientists know a lot about your data, and they will probably have some labels for your data so they can compare it with the label and also the results from our service. And the business side is also important here because they are the final person who use this service. So they have to validate from their side whether it is detected right or wrong, and whether it is making sense or whether this anomalous extent is looking good to them. So these are some personas that will be involved into the validation and also the using scenario. And then let's go to a more complex one, which is the multivariate anomaly detection. So within that, we have a set of APIs that can help you do the training, inference, and also other operations on the model. So I can give you a quick through this chart. So first we have a training model API to train a model, and then you can use the get model status API to get the status of that model, whether it is running successfully, whether it is failed, or is still running. So you can get the status, and you can also get the epoch ID, which is indicating the process on your model training. And after you train the model, you can trigger the inference. So the interesting thing here is that you can either choose the asynchronous inference or you can choose the synchronized inference API. So these two APIs, the difference between them is that for first one, the asynchronous one, you will not get the results immediately. That is because for asynchronous, we are mostly using them in the validation scenario. So, for example, you have a data size for 1 year, and you want to use this 1 year data for validation to do a batch inference to see whether the results is looking good to you. So, this is more like offline validation, and you will give a lot of data into this API. So, due to the limitation on the response and also the request body, we will not give you all the results in the request body because that will be a 1 year's results, right? It's super huge. So we will just give you a result ID, and you will use this result ID to pass into another API called Get Inference Status API. And with that, you can get your status of your inference and also guided inference results for this. So this is two different API, and the other inference API is the synchronized one. So within synchronized, you can do some streaming detection. For example, you can detect one data points at one API call within one API call, and within that, you can immediately get the results whether this timestamp is anomalous or not. And also, you can see more details like this. So I just used some visualization to present the value of this result. So first you will get something like this, the right bar. So you can see the right bar is some anomalous. So that will tell you the anomalous timestamps within the results. And the second thing is that we will tell you the top contributors, because for example, if you have 100 or more than that variables, you don't have enough time to read through all the time series. And also it's really hard for our experts to do that. So what we help you is that we will give you the top contributors that contributed to this anomaly. So you can based on this top contributor rank to see whether which sensor is the top contributed ones. Let's say this sensor 1 is having the top contributor ranks, the number is the largest. So that will tell you that at this timestamp, this sensor 1 is the most anomalous one. And also, behind this, we will have a third details on the root cause analysis. So we will tell you the correlation change the values and the variables. For example, the sensor 1 and the sensor 10 have a correlation, but at this timestamp, their correlation changed a lot. So we will tell you that this timestamp, the sensor 1 has anomalous and it's the top contributor, and another sensor, which is called sensor 10, that has great correlation changes with him. So you can, based on this kind of information, to do some root cause analysis or do some actions based on your understanding on these sensors. So these are the magic of this multivariate anomaly detection. And also, I will show you a technical overview. It's also simple to understand. So you can get your variables from your system, all your equipment, and then you will do the data processing and training and train a lot of models based on your variables and based on your data size. And after that, you will use the training model and also the same schema of your data size and use that into the inference API and inference on real-time data, or you can also do some validation like the batch or a macro batch inference. So after you do the inference, you can get a validation from the data scientist and the business side. It's also the similar from the previous one. So that's all for the technical overview. And a lesser thing why we need this anomaly detector, that is because we have some values for you. The first is that we have the simple REST APIs and SDKs, so it's easy to use. You don't need to build your own model to detect on your equipment or system. And especially for the univariate, it's model selection work, so you will not need to build every model for every data pattern. You just use one API to apply on all kinds of data size. So that's the first one. And also within that, we can detect different kinds of anomalies, including spikes and drops, deviation, and also some trend change or level changes. And also for the multivariate, it will detect the correlation changes. It's also a really important thing that most engineers and the maintenance engineers is caring about. And the second is that we will not need your label at all, because sometimes the customer will want to build some like supervised model, but the question is that they don't have enough label to do that. So that's the reason why we leave the supervised alone and we use the unsupervised model for end users. And trust me, the performance is also good because we compare with other like supervised models. We can say that we are like have a really better performance beyond them, but we can definitely say on the case of you don't have your labels or enough labels, the supervised model could definitely give you a good results of your anomalies. And the third is that the cloud and edge support. So for now, these two services are all online, so you can use the API to call them directly. And for the univariate detection, we are also supporting you on Edge, so you can deploy on Edge and deploying on your equipment, etc. So these are the value propositions. And also, let's have a further saying about the predictive maintenance. So with the Azure multivariate anomaly detection, with this feature, you can definitely to predict anomalous before it happens, because sometimes we don't want a pump to crash or to go to a downtime really quick. We want to detect anomalies before it happens. So with this multivariate, it can sense the anomalies that happened before a disaster, and it can detect many patterns of anomalies, and it's also easy to use and easy to integrate. And also for the root cause analysis, this will also tell you a lot of things, like I just mentioned earlier. So let's come to the topic today. After you know a lot of knowledge and also a lot of information about our service, so let me tell you 5 popular ways to use a anomaly detector. So the 5 popular ways are indicating that we can use 5 popular tools or 5 popular applications in Microsoft to use anomaly detection, instead of you just build on your own notebook or other places. So the 5 popular ways are this. Okay, so based on this icon, I think most of you might be really familiar with them. So the first one is the Azure Machine Learning, and the second is the Synapse Analytics, and the third is the Azure Databricks, and the fourth is the Power BI, and the fifth is the Azure Data Explorer. So I also listed the current supporting on these 5 popular ways. So in the first three, in AML, Synapse, and Databricks, we support both univariate anomaly detection and also the multivariate anomaly detection, which are shortened for UVAD and MVAD. And for the last two, the Power BI and the Azure Data Explorer, currently they support the univariate anomaly detection, but the multivariate is working in progress. So you can also stay tuned in our community, and also I will share you more about the details here. So how you use them and where you can use them, I give you a reference architecture of them. So first, you can see this anomaly detection part is indicating the 5 popular ways here, and the difference between them is that in the first four, you can also integrate with other Azure components like the Azure Event Hub or other storage, and you can use some alerts and notifications to build some alerting and notification system. And after them all, you can use some Azure components or other components to do the visualization or for the implementation, like the app services, Power BI, function apps, or the Power Apps. So the reason why I list the Power BI here alone is that within Power BI, you can do a lot of things, but currently it only supports the univariate anomaly detection, and based on the coding way, it just have less flexibility, but it will all depend on your scenario. If you are just a business planner, or you are from a business side, or you just maintenance engineer, you don't want to write a lot of code for the univariate, you can definitely use the Power BI to do all of these things, because in the univariate in Power BI, you can first create some line chart and then apply the univariate anomaly function and then use them to do some visualizations. Also within the Power BI, you can set alerts on that. So that's the reference architecture for these 5 popular ways. And next, let's go for each. So the first one is the anomaly detector in Azure Synapse Analytics, which is also a great collaboration that we have with the Synapse team this year. So you can see here we have actually 2 different ways to use that. So for univariate, you can either use the low code way or a notebook way. So the local way is really low code. You don't need to write code at all. You just paste the code from the documentation, and the code is more for some settings for the parameter instead of writing some logic or really complex codes there. So within the Azure Synapse Analytics, after you ingested your table or ingested your data, you can right click on your Spark table, and there is a thing you can choose for predict with a model. And with the predict model, you can see there are a lot of content services presented on there. So you can choose the anomaly detector for the UI function. And after you choose that, you can set something like this. So like I just mentioned, you don't need to write a lot of codes, and you don't need to write some complex logic. You just use the parameters. You just setting the parameters, and to setting the column name of your parameter, like the output, error, and the timestamp, and also the value, group, etc. So after that, you're all done. You just use the anomaly detector function and to print the results here. So you can see after you run just like 20 lines of code, you can get the results like this within your Spark table. So within this Spark table, you can get whether this is an anomalous timestamp, whether it's true or false, and whether it is positive anomaly or a negative anomaly. And also you can see the value and timestamp of your previous data. So this is a really easy way to do that. And for the multivariate, currently we don't have a UI on this, but it's also working on progress. And for the multivariate, you can use the Synapse ML. In for Synapse ML, you can either use the multivariate or either use the univariate. So the Synapse ML, I will give a quick introduction. So this is an open library from Synapse team, and actually is called Spark ML before. So in this Synapse ML, it contains a lot of modules and functions. For example, in this Synapse ML, you can use the anomaly detector to run this. And the reason why we can use the Synapse ML instead of the raw API or SDKs of multivariate anomaly detection is that in this, we simplify the data preparation way. So in previous multivariate anomaly detection, you have to prepare your data in different CSV files and zip them into a zip file, and then upload to a blob storage, and then upload to the blob storage, and then to generate some SAS token. And then you can do the training and precise. But in Synapse ML, it supports all different kinds of data source instead of just the blob storage. So you can use your Coastal, use your Circle, use your CSV, as long as it's supported by Spark, by the Spark environment. You can use the database for this. So it's pretty simple, and you don't need to spend a lot of time on preparing the data. And after that, you can just run your Synapse notebook. So I can give you a quick show about how you can run this. Okay, so this is the Spark demo notebook that I have built previously. So the function that we use is pretty simple. So the method is that you first create some resources in your Azure portal, like the Synapse Analytics and also the Anomaly Detector service. And for example, some people might use some keyword to store their key and connection string, etc., because they don't want others to get access to it, or they don't want to present this to more audience. So they can just create some keyword to store some important things. So I can show you something like here. Yeah, so this is the keyword I create, like the Spark demo. The Spark demo is the name for my keyword, and also I will send the name for the anomaly detection key and also the connection string to my blob storage. So after I create all this Azure services resource, I can go to the Synapse Analytics workspace. And then I can create a model, create a notebook. So you can see there is a develop button here. You click this and go to this notebook and create a new notebook like this, or import a notebook that I can give you. So all these materials within this session, I will send them into a link, and I think our host will also send this link to you in the session later. So don't worry that you don't have enough guidance. You have a lot of materials to read. So please stay sure on this. And let's go back to this notebook. So you will use the Synapse Spark pool, and the Spark pool is also attached here. So you have to manage a pool, or you have to create a pool. So it's more like a compute environment. After you create that, you can attach to your compute. And then based on your version of your Spark pool, like the 3.1 or the 3.2, you can use a different configuration on this part. So it is also provided by Synapse team. You just copy them, and to change the version here, then here you go, and you run this section, which might take around like 5 or 4 minutes. And after that, you can import your modules like the Synapse ML, which is the really important, it's the most critical one here. So within this, you can use every cognitive services module within just one piece of code. And then you can also import other like important modules like the NumPy and Pandas and also others. And I also import the matplotlib, so I can show you some show you some visualizations at the end. And after that, you can prepare your data and load the data into a Spark data frame. So my data is stored in the blob storage, and it's a CSV file. So you can see the path is something like this. And this is the protocol I will use for this data ingestion. And yeah, I also do some transformation for the format because I want to make sure the format is good. And then you can see the results of the timestamp and also the sensor, which is the raw data for my cases. So we have 3 sensors and the timestamp here. And after that, we can go to the training part. So within training part, all you need to change, or all you need to do is just some basic settings of your non-detection key or your connection string, and also your data type. So I just use the keyword to indicate and initial the connection string and key here, and I also specify my information for the data, like the start time and end time that I will train, and also the timestamp column, and also I will indicate the input columns, which are all the 3 sensors, and also I will use a container name to store the intermediate data, and also this is an intermediate data folder for this because the Synapse will do some processing on your data, and it will help you to transform the data into a way that the multivariate MVD supports. So you need to store the intermediate data in a place that you indicate. And also you can set the locations of your non-detection resource. So I will use the US here. And yeah, all these settings are for the training part. After run this really quick, like 5 seconds, I can then train a model. And because the data I input is not that large, so it will just take a few minutes to train a model. And I can tag the model. It is in the Synapse ML library. It's using the detect multivariate anomaly detection function. And after I train a model, I can use my data set to trigger an inference. So the start time and end time is the time I want to do inference on. And also I can set some column name like the results and also the errors because I'm interested in whether there are some errors and error codes behind this. So it also runs really quickly around like 6 seconds, and after I trigger an inference, I can get the inference results because currently we are using the asynchronized inference in the Synapse collaboration. So we can use this path definition, this function to get the results. And also I want to print them in a good way. So I also separate different columns from JSON to this severity, series, and etc. So I will give more information here. So the timestamp sensor 1 to 3 is the previous dataset I prepared for this training and inference. And this is anomaly is the basic results for whether it's anomaly or not based on the true or false. And this is another thing called severity. So severity is a number between 0 to 1. It indicates the severe extent of this anomaly. For example, if this severity for this timestamp is 0.3 and another severity is like 0.5, then which means at this later timestamp it is more severe than the first one. So if you don't have enough time to look all these things, or you want to figure out some false positives, you can definitely use this severity to set some threshold, like you set threshold at 0.5, and you can filter out all the anomalies below the severity of 0.5, and only keep the severity above the 0.5. So this will help you to reduce the false positives and also help you focus on the true problems. And behind that, these 3, 0, 0, 1, 2 are the contributor score for these three sensors. So you can see the score is something like 0.15, 0.25, and 0.59. So it's also similar to the severity. If the value is larger, then it is more anomalous compared to others. So in this case, we can see the last, which is indicating the sensor 3. The last sensor is having the top contributors among others. So in this case, you can say that we can only focus on the top one, the sensor 3, because at this timestamp is the most contributed one to this timestamp. Okay, so this is the results for anomaly detection for multivariate, and also you can see the visualizations here. So I will use some MATLAB plot, and I will draft something like this. So you can see the red part is the anomalies that detected from our service, and also the black line. The black line here is something called severity of detected anomalies. So it will also indicate the severity score. So you can, based on this score and based on your real case, based on your labels, to filter out the real anomalies. And then this is the top contributor of each sensor. So you can see here the sensor 1, 2, 3, they have different colors, and the longer the color is, then it is having the most anomalous, because all these contributors score summed up will be 1. So we will use this kind of charts. And also I zoom into 1 so you can have a better view of this. So within this one, you can see there is a big drop of this time series, and within that we also have a lot of vibrations there. So you can also to see whether this is anomalies or not, and how you take action on. And also in this part, you can also see there are anomalies, which is really clear to people, and our service is also detecting it in a red way. Okay, so that's all for the first option for the Synapse one. So let's go to the next one. And the next one is the Azure Databricks. So within this Azure Databricks, you can use the notebook, and which is a really similar thing compared with the Synapse one. So you first create a Spark environment, and you then attach to the Spark compute, and then you can run the demo. Whether you can use your own demo or you can use my demo that I will present, that I will show and share with you later. And after you train the model and do the inference, you think, oh, it's in a good way. So you can use the schedule part. I'm not sure whether this is a little bit small to you, but I can also switch to my browser to go to the here. So you can see after I train all this thing and after I got the results, yeah, it's pretty similar with the Synapse one, and I can schedule. the schedule here will help you to schedule running automatically. So for example, if I separate my training and my inference in two different notebooks, I can like set some scheduled inference like every day or every day which time I can run this inference. So this is more like a scheduled one. So after I do this, I can have a pipeline solution for my anomaly detection. So this is the second options for the anomaly detection service. And the second is that you can also use that in Azure Machine Learning, because it's also a similar way to use that in the Azure Machine Learning compared with the Databricks and the Synapse one. You will use like a compute, you will build some compute instance and attach your notebook to this compute instance, and then build a notebook. And this notebook could also be written by Python, so you can use the API or either the SDK sample. So you can just import a notebook and change the important settings and configurations and run your own code. So this is basically for the top three ways. And the top four is the anomaly detector in Azure Data Explorer, which is also known as Custo, because some customers might store their data in their Custo. So you can either use the Custo in your web service or either in the desktop application, which is called Custo.Explorer. So the rationale behind this is also pretty simple. So you just run a query, you just write a query write function, and within that function you should enable your plugin for Python and for an API call. So within this function, you can just call the API directly. And this is the results for the anomaly detection results. And also you can see I have a code snippet here. So enable some plugin, you add your database, and also you can use the URL, URI, and also within the headers, you give your subscription key for anomaly detection. And also there are more details here. So you can use the Python language to import all the thing and to detect anomalies on that. So which is also a good way, because the customer don't need to go to a separate way to train a model or do the inference. But one thing I need to call here is that the ADX only support the univariate now, but we will definitely working on another the multivariate one. Okay, so next is the anomaly detector in Power BI, which is the less popular ways. So within that, first I will show you there are two ways. The first way is a find anomalies function. So after you create a line chart like this, like the revenue over time, you can see that after this, you can see there is a find anomalous. So within that, you can just use some easy setting and some choosing and add anomaly detection on your line chart. So you can give some results like this. And at the same time, you can also format your anomalies and adjust your parameters. So you can choose the size, choose the color, and also you can choose the sensitivity. So this is a really critical parameter that you should adjust, because it will indicate the numbers of the anomalies. For example, if you think there are a lot of anomalies that you don't care and you think there are just false positives, that means this kind of model is too sensitive about your data. So you just decrease the sensitivity from around like 80% to 70% or lower than that based on your case, and to select a better parameter for this sensitivity. And also you can see the other settings here, like the anomaly shape size, the shape for that, and also the expected range style. The expected range will show you the lower margin and the higher margin about this anomaly. So this is more like a predicted or a forecast values, which is a range or a band. So if the anomaly is beyond or below this band, that it will be marked as anomaly and will be something like this part. Okay, and also you can configure the explanations and add them to the report, because sometimes the revenue, for example, this part is calculated by other things like the revenue for different category for different countries or different regions, etc. So you can based on this combination and also to configure the explanation and use the explain by to filter out. For example, I explain by the city and the seller. So once there are anomalies here, I can see whether there are some same or similar patterns based on the revenue for my city. So you can use that to do a root cause analysis to see which category or which dimension is the top contributed for these anomalies. Okay, so this is the first way, and the second way is more powerful. So you can use the Power Query in the Power BI, which is located in the advanced editor here. So you can click that and to add a new query for it. And with this new query, you can write something like call this univariate anomaly detection API and to get the results and also get more details like the upper margin, lower margin, and also you can get the whether it is positive anomaly or it is negative anomaly. So based on these values and these results, you can also make further or advance the settings on these anomalies to do some filtering or other things. So this is the one that I use for the Power Query. So after I apply this Power Query into this, you can see here we have like different parameters like the value, up margins, lower margins, expected values, and also I can do further advanced setting or further calculation on this, which it will be more powerful and flexible than the previous way. So this will be a more customized and it will give you more insights. Okay, I think that's basically all for today's session. And really important thing is that first you can join our Teams channel for further updates or any release. And also for the resource of today, I include all them thing into a GitHub repo. So you can just use this link, aka.ms/AD material. AD is a non-detection here. So AD material to get all the information within these 5 popular ways, because the time is limited and I cannot show you every details of each ways. So I just give all the thing into this repo. So you can use this repo to deep dive. Like the Microsoft Learning, you can use this learning module to learn how to use the univariate and also the multivariate. And also there are the API and SDK sample to help you do a really quick start. And also there are the the different popular ways like in Synapse, in Databricks, in AVX, in Power BI. So there are some blogs and documentation. And also if you need support or you want just to get updated or you want to like hear about some updates from the product team and also to join some discussions with other customers or partners, just to join our anomaly detector community for better communication. Okay, so that's all for today's session, and thank you so much for joining. And next part, I think I will leave some time for the Q&A. So please, our host, Albina, can you help me to stop sharing so I can go to the comments page to see the questions and read them aloud? Okay, good. Okay, so I see a question from Control Solution. So the question is, if the data have NANs and have some AD, some features, does AD have some feature to manage that? Yes, we definitely have something like this. So if your data have some NANs, for example, in your multivariate and also your univariate, you can use our filling NA method. That is also integrated into the anomaly detector service. So you can use this fill method to trigger and to to fill the method. You use different methods like the previous or the linear or a fixed value, etc. So yeah, that's for this question. Okay, if no more questions, then we can stop this, and looking forward to connect with you further in future. Thank you so much. Bye bye.